Oh, right. And then just as a PhD, my usual 11 for the class, so I'm really having I think it would be like this one going. Just deciding the last time we used the January and now there's something now. I got one or two small things and then
Oh, you got the video, so you
Yeah.
Okay. So we are good to go?
Good, welcome everybody. Please grab some pizza if you haven't done so already and then get seated and get started. I know some people have to leave early and we want to hear everything that Xiaoyan has to say. So, and also, of course, a belated Happy New Year of the peak for everybody. For those of you who celebrate Lunar New Year, that was on the 5th, right? So yesterday, right? Was yesterday? Okay, good. So then it's not too late to reach that. Yeah, so last time we met here, Guoja gave a presentation, right? And the idea is still this camera array that we have in NSF, major research instrumentation grant to build it. There will be 50 high-speed video cameras. And last time Guoja introduced the concept and the hardware that we're looking in. And then there were more questions than answers. And so we felt maybe this time we try again after 1 week of testing. And Xiaoyan can show us a little bit more about the concepts and what she has found out about the cameras. We still haven't, there's a few things that we want to still look into, and we haven't placed the orders yet. So if you have any more suggestions, please let us know. Okay, so with that, Xiaoyan, go ahead.
Thank you. Hello, everyone. My name is Xiaoyan, and my advisor is Dr. Mueller, and I work with Guoja, Brianna, and Rhea on the project. Today, I talked about the camera testing results. So now we need to select the camera and the lens. We have two types of cameras, monochrome and color one, and lens with 8 millimeters and 12 millimeters. For the test objectives, is two objectives. First one is a field of view, both in horizontal and vertical. The second one is field of view with the different apertures, because we want to kind of trade off between the depth of view and the light sensitivity. The parameters need to be tested are also two parameters. The first one is after we have 4 values, f1.4, f4, f8, and f16. With the larger values means the aperture is smaller, means less light will come into the camera. And the second one is focal length. For this, for the lens we have. We have the focal length from 0.1 meters to infinity. But between the 0.1 and the infinity, there are 5 fixed values. You can see that on the picture. So here, those numbers are the apertures 4 values, and these values are the focal length, infinity, and there are 5 other points, fixed points.
So you lock the focal distance?
Yeah, C is locked. The method of testing the field of view of this is Guoja for the board. The method is that we make some marks on both on the screen of the camera and also on the background board. We make a cross, and then we kind of overlap those 2 points, those 2 lines to align them. We put a measurement, a tape measurement, attach the background board so that we can tell the distance. We set the distance between the camera and the background board 1 meters, and then we take clear pictures, both in vertical and horizontal and vertical. And then this is a draft. We can get the So this is the distance between camera and the board is 1 meter. And from the picture that we got, we can get the distance between the distance of the horizontal and the distance of the vertical that the camera can capture of the background board. And then did some calculations. In this one, we tested the focal length with 12 millimeters. This is the final result. What the vertical angle of view is about 31 degrees. The horizontal angle of view about 38 degrees. And we compare our result with the datasheet that we got from their online website. This is the datasheet of a 12 millimeter lens. Go down here. This is angle of view for horizontal. They have the dataset shows that the horizontal angle of view is 40 degrees and the vertical angle of view is 30 degrees. Compared to our result, it's very close. Yeah, and this is the datasheet of the lens with 8 millimeters. So the detail here is the horizontal angle of view is 56 degrees. The vertical angle of view is about 44 degrees. It's a little bit bigger than the length of 12 millimeters.
By the way, does anybody know what 2.2/3 type megapixel camera? What that means is that the kind of sensor.
It's the size of the sensor.
The size of the sensor. Yeah, I expected that. Okay, good. And then we have 2/3, not 1/2. Is that right?
Yeah.
Okay. The next step is to test the depth of view. This is a figure to explain what is depth of view. So, on the left hand of the figure is the target, and on the right hand of the figure is the focus plane. So, for example, on the point, I think the green line. The blue line point is the target, and and it projected to the focal length exactly on the focus point. This point here is the focus point. But if we have a target that before or after the focus point, after projected on the focus plane, it will become a circle. It's not a point, it becomes circle with a diameter of c. So for our human eyes, we have a tolerance. If the circle is not that big, we can assume it's a point. But once the circle is large, the image will be blurry. So we cannot want to figure out the nearest point and the farthest point that the image is acceptable. So the distance between the nearest point and the farthest point is what we call the depth of view. So there are 2 points to decide the depth of view. And the method of testing the depth of view is, so we use a focusing pattern. This focusing pattern is mainly used for the focusing testing in photography. So we use these patterns to test our cameras. And for our cameras, you see there are some green lines. It's focus aid that if the camera can detect the patterns, for example, the black and the white edge clearly, then it will show green lines. More green lines on the patterns means more clearly. So I'll show you a video. You will see the green line start showing off and fully distribute, and then start to disappear. And yeah. So the point. The point, maybe this point, when the green line is fully covered on the plane, that means it starts to fully focus on the target. And when the
That's not really depth of field the way I think of depth of field. The way I think of depth of field is when this object is in focus, how much in front and behind it is also in focus?
Yes,
And you're telling me it's
it's a distance, it's a range of.
yeah, it's the range of the field, but how is this measuring that?
Oh,
I mean, you could put now another object in the middle of this range, and so that's around. So there's
So
one.
this somehow tests. Okay, I don't understand how it tests that based on the.
But it's just instead of showing the objects at the same time, it does it one by one. Right? It just goes through, sweeps through, and says, okay, so the focal length is set to a fixed value.
Yeah.
Right? And now you go through and you say, okay, that's too small. It is blurry. Bigger, bigger, bigger. Aha, now I can see it clearly, and then not clear.
Okay.
Right? So that would be if you had another object, say in the first position, that would be the depth. We just do it only one at a time, but it's the same measurement.
Okay. And you're adjusting the f-stop on this? Because you have to adjust, because that's going to depend on the f.
Yeah. I mean, one
and the
experiment,
amount of light you have.
everything is fixed, but then they repeat the experiment, changing the f-stop. Yes, and we'll get to that result. Yes.
Okay, cool.
multiple test.
Mhm.
So this is how we defined the depth of field. Back to the slide. Yeah, this is the method, and then this is the example to show the nearest.
So that's slower, but at the same time.
Yeah, the nearest farthest point. Okay, and then this is the result of the depth of field. So the first one is combinations, and then parameters. We set different focal length, infinity. Oh, sorry, I didn't change the marks.
Okay.
Okay, Mark 2, Mark 3 is let's go back. It's on the length. There are 5 marks. So we mark it.
Focal length.
Yeah, focal length.
Yeah, so different set.
And then we change the aperture to f1.4, f4, f8, and for 2 different cameras, monochrome and the color one, and for 2 different lengths, 8 millimeters and 12 millimeters. And the proximal end is the nearest end, and the distal end is the farthest end. And we we got the distance is the depth of the field. So from the table we can see that. For the monochrome 8 millimeters, we can get the best result. The nearest point is not that far from the lens, and the farthest point is larger enough, maybe because our flight tunnel, maybe the diameter is 1 meters. The diameter is 2 meters, so 1 meter's focal length may be at least enough for the best flight.
So the idea is that we can talk about exactly how large we want to make it, but the idea is that in the middle we would have a region that the bat is, well, whatever animal, it's not limited to bats, that the animal is supposed to fly through, or if in a successful flight it would fly through, and that would then be 75 centimeters. And we have to talk about, I think we need another test to see, but if you actually have the typical kind of markers that we put on an animal, right? Maybe even if it starts to look a little bit blurry, right, you could still do it. So I suppose that if you go for this test pattern there, it's probably very conservative, the 75. So we have to see, right, maybe also try, maybe with Java, you can try an image analysis of move an artificial bat wing with the markers and see how far. There's the field of view, and then there's the area where tracking would still work. And my hope is that it is a bit more than 75 centimeters, maybe a meter or so. So the idea is we would have a meter in the middle, and then we would move the cameras a bit further out so that we account for the region that it doesn't work so well. And then maybe if necessary, you could still deny that area to the animal, maybe having some thin filament or so that it, and if occasionally the bat or the animal does fly too close, well, there's so many runs, right, where it doesn't work because you want the animal to fly and instead it just drops down or whatever. So you never get 100%, but we would make it a bit bigger and say, okay, if it flies where we want it to fly, then the thing is in focus, right? So we were thinking making the ray about 2 meter diameter. Maybe now that we see that it actually starts already 30 centimeters or so, maybe we can do 1 meter 60. But I think we'll play a little bit more and decide. But somewhere around that, and then we have that middle corridor where we can actually get useful data. That's all at the moment the thing.
But the color camera is much worse.
That because there is a RGB filter in front of the sensor, so it will block some of the light. And we found that the light can help to increase the depth of length.
Yeah.
More light, yeah.
Well, it's like you're losing two stops of light, but you're also taking the pixels and probably averaging the pixels. So you lose resolution
Yes.
as well. So I missed this here. So these are two different lenses.
Yeah, so we have two cameras, two different camera bodies, one monochrome, one color, and then two different lenses, one 8mm and one 12mm. And so we are now trying to decide what should be on.
So is this coming up next? But you have to consider the resolution as well. Did you do a resolution test?
Yeah, the company has that on its webpage, but did you bring that?
But the companies, you should ignore the resolution completely.
Okay.
You have to do your own test because it's a combination of the sensor, whatever lens you have.
Yeah, they have some test images on their website, but we have to do it ourselves. It's true. Right? I mean, also for the field of view and for there's things in the manual, but we measure. Right? That's right. Yeah, we should do that. But there are some images already available, but yeah, we need to measure that.
Can you give me an idea? What does an 8mm lens mean on this camera? I mean, if you use like a DSLR, then you need a 50mm lens is about what we see. What the hell is an 8 or a 12 in this
lens?
This super fisheye lens?
Because the size of our sensor is much smaller than the DSLR, so the angle of view will be part.
That's a super if it's a
If you have a 8mm lens for full frame DSLR, it'll be super wide. But our sensor is just a two-thirds sensor, so it's.
So what's the
basically
equivalent?
lens.
What's the equivalent on a DSLR?
I don't know the exact size, but we can tell from its angle of view, which is shown in her previous slides.
So about 30
I would say
in the
it's
vertical
about
and
50,
40.
50 or 35 in the full frame DSLR. Their angle of view are basically the same.
To kind of summarize, we found that the lighting will help the focusing, and the monochrome has better depth of view, and this is the result of 8 and 12mm lens deformations.
So I think actually technically the monochrome versus color, the depth of field is exactly the same. The depth of field is set by the lens. You didn't change the lens. I think you're looking at the effective resolution, and that's what's going to be changing there.
The resolution means if the picture is hyperpixel, is it clear enough? Yeah. Right.
So the way that you're figuring out the depth of field is partly by looking at the test of the resolution. Those things you're intermixing those two things.
So the color is effectively a lower resolution.
Yeah.
Yes.
Yeah, you have the same number of pixels, but because you have a green pixel and a red pixel and a green pixel, you don't have any green information in the middle, so when it interpolates the value, it effectively smears the resolution.
Does it mean it's a higher resolution because I can focus out to 1,000 meters?
But this says nothing about the resolution. But the way that she's figuring out the depth of field is a measure. They're using resolution to figure it out. So this is effective. This is like an effective practical table. So this is what you're getting in reality. but it's not telling you what the depth of field is of the lens itself. That's something.
I thought
That's something independent of resolution. So you could have a sensor that was 4 pixels. Your resolution would be terrible, but it's the lens itself would still have the exact same depth of field.
I thought the depth of view is in a certain range of distance that your picture is clear enough, it's high quality.
Yeah, exactly.
Yeah.
So that's the definition. That's the definition. But your sensor could be whatever. Optically, the depth of field is an optical character
of the lens.
of the lens. Yeah.
I see.
Yeah, so do we know what the size of the lens was on the previous GoPro 4s that were used? Or do we have an estimate of that?
Yeah, that would be really, I think that's a good, I don't have that numbers, but we have some in the lab. Right? We have some GoPros in the lab, is that right? So we could, I think it would be nice to run it next to it, but also when we design the array, right, that we get a sense how much. I think the field of view is probably narrower. Do you have a sense? That if you hear now 30 to 30 degree in one direction, 40 in the other. Yeah, for the GoPro, is that wider?
It's pretty wide, yeah.
So that might be interesting to know, right? Also, when we consider the camera placement, if we have a reference, right, is it just half of the GoPro, or is it 70%? It might be sort of, right, when we know we put the GoPro's distance and how then should we place those cameras, that would be indeed good to compare that, right? And so since we want a little bit more testing, right, take some more test images, see, right, the image reconstruction, right? So what is sort of, instead of taking the definition from the autofocus image processing, we take our own image processing. What if we want to track a 2 millimeter landmark, right? How close can it be? How far can it be to do that? And then with this number, we can then go to design the array, and then we can, if we do those tests, compare it to the GoPro, so that we get a sense. With the GoPro, it was this, and we had them this narrow, and maybe we need them, have them spaced a little bit more. My sense is that the GoPros, I don't know, those of you who have looked more at images that they were unnecessarily wide, right? That you get you get the bandstand from many cameras, but you really only need the 2 or 3. I mean, you need only 2 cameras, right? And so typically you would actually pick the 2 best ones, right? And if one camera has it in the edge of its field of view, you wouldn't use that anyway, right? So smaller field of view is probably no loss, right? Is that do you think that's your experience?
Yeah, the biggest problem is the radial distortion gets really high towards the outside.
Exactly. So you cannot use it anyway, right? So that's also something that we should test with those cameras, right? How much distortion is there, right? So can we actually use the entire field of view, or sort of effectively? So I think we should do some image testing. Just take images with the same lens and then monochrome versus color to see what the image quality looks like. Again, there are some on the webpage of the company, but I agree with Jake that you should do it yourself, although it's the same body and the same type. But nevertheless, I think from my interactions, I have a very good impression of that company, right? But nevertheless, we should do this. We should measure distortion. But I guess just take a picture of the grid and see if a grid comes out like a grid, or if it's something. You can use the GoPro to see what distortion looks like. I think that it's probably the GoPro is the compendium of nonlinear image distortion. So you can test that, and then maybe we can move. I mean, from what I've seen here, my sense is monochrome 8mm is the way to go. Or is there any other thoughts on that? We want to test that, and also what hasn't been tested is pulling the images off via Ethernet. That has not been tested either yet. Again, I know that Nyla last summer she has done it, so it can be done. I know that the manual promises gigabit Ethernet connection, but I don't know. Lucas, do you have any experience? So if it's specified as gigabit, does it actually always give you gigabit, or would it be just 80% or 50%? Do you have any sense?
It will really depend on the length of the wire too. So like longer it is, also the type of the wire you're using, like so like a Cat 5e or a Cat 6, depending on which wire you're using.
Oh, good. So that's also something then to test.
Yeah.
Because you can test, but what do we think? But the array will be a couple of meters length. So you want the maybe 5 meter cable or something. Make sure when you test it, take a 5 meter cable and see what you get over that. So I mean, we know the camera has 16 gigabytes of storage, and that is enough for a bit more than 8 seconds. So if we shoot for 4 seconds, that would be half that. So you would have to pull 8 gigabytes of the camera. So if the gigabit was what it promises, then it would be 64 seconds. So if you so it would take a bit more than a minute to pull the data off then in theory. So now we have to see what it is in practice. Which I think if it was a minute, even if it was 2 minutes, because if you do a trial run with an animal, you have to retrieve the animal and put it in position. So having 2 minutes between or 3 minutes between runs, that's probably no big deal unless you have an animal that executes a natural behavior again and again by itself. But if you have to sort of carry it from one end of the tunnel to the other end and put it in position again, then maybe 2 or 3 minutes is nothing. You will need that anyway, and then probably that will not limit the workflow.
But be dependent on how quickly the other side can receive that data. So that'd be something to make sure.
Yeah, there's that particular. So we need a switch, right? And this, so the switches, do they have enough bandwidth for all their ports, or how is that usually?
That would be really dependent on the hardware. And
depends on. So we have to obviously get a good switch, and then there's the question, right? Will the PC then or the file server, will that handle the data flow? If we have 50 cameras and they're all sending, right? Will it handle those? Can they do multiple? Maybe we want to have multiple gigabit Ethernet cards in that file server. Then that would help. But maybe that's what we want to do then. Not exactly 50, but we could put in 4, depending how many slots we have, or 8, and that could then hopefully we'll see. Right? Maybe start with 2 and then add a third one and see does it still get better, or at some point the CPU and the data transfer will kill us. But it's so everybody knows, right? The plan is 50 cameras, right? So that will be quite a bit of data that we are putting off. And of course, it's then visible if you run the experiment that you plan and you really record. You set your time recording window to what you really need. Right? So don't be over. I mean, you don't want to miss any interesting action, but you don't want to be over generous either, because it's all multiplied with 50 and then 1,057 frames per second. That's per second. If you add, it's more than 50,000 images. Okay.
Yeah. So how many cameras do you guys have right now for testing?
We have 3 of them. We bought last summer. We bought 3 color ones. So we have 3 color ones that we own, and then we have 1 monochrome camera that the company gave us as a loaner so that we can test against that. And so we also, when the monochrome, the color cameras, they came with 12mm lenses. Is that right? Yeah. So we have 3 color cameras, 12mm lens, which, I mean, so last summer when Danesh said that the field of, the depth of the field was not so good, was abysmal. That is sort of.
I didn't say this.
Yeah, okay.
I said it was.
Yeah, but I'm German, so I say it as so was not so good, and because we had of all the combinations, we had the worst one. And I don't know if the f-stop. I mean, the images were quite clear, right? So I think you could have maybe reduced the aperture size and maybe trade. Maybe the people who recorded, well, they could have traded a little bit less light, a little bit less brightness for a bit more field of view, but it was the worst combination, right? And we of course plan to go now with the best combination, not with the worst. And again, I think we should test that. Like what I just use your point picking program and try to pick the points and define depth of field that way.
You can have a black surface with white dots on it and just move it.
Yeah. Make a little cardboard bed wing with some points on it, move it a little around, and see, can you track it? How close to the camera can you track it? How far away can you track it? And then based on that, we will make the final decision what the diameter of the tunnel should be, right? And so it will be, and at the maximum depth of the endpoint is sort of on the other side of the inner that diameter for the cylinder that we can record. And that's the plan.
Perfect. You have several C-mount lenses that I bought for different cameras. So if you want to try a few more,
I think that's a good idea. Yeah, by
mount is universal. I mean, C-mount is standard.
Yes, exactly. And I mean, the company only offers a limited range of, but we have the cameras here, right? So we can actually test, right? So we, is it good? Yeah, no, that Cheyenne, if you could take with Alex and take them and take a look, well, maybe there's something where, oh, that is so much better. Yeah, and I mean, with the company, that they budget that the lens is extra, right? So we can say we don't buy, we decided not to buy your lenses. We can, they might was 50, but the lens is I think $150, right? So a piece. So they will try a little bit, but probably not so much. And if we find something, the overall budget we can also not change. But if we find something that is similar from another supplier, another lens, and it's just a few dollars more or a few dollars less, that you have that slack in the budget. Yeah, no, that's good to know. Let's try a little bit more and see what that might buy us, and who knows. Right? Yeah, good idea.
Yeah, I mean, I would say, I know your budget limited, but you can get a wide variety of. I mean, there's a wide range of quality in glass that don't change the resolution of the system.
Yeah, no, let's test a little bit. I mean, these results, they are not bad, right? I mean, this just looks pretty decent to me. But before we can spend that money only once, and we should look a little bit around before we spend it. That's definitely in there. And by the way, also the next thing to choose then is we also need lights, right? So for the tunnel to light them. So if any, and the truth is, I have no real good idea what a good camera light is. So if anybody here has any suggestions for camera lights, that would be good to look into. I mean, otherwise Google shopping will be our thing. But if anybody has some suggestions here, I have a really good camera light in my lab, and why don't you look into this company or this type of light, and then let me know. But maybe we can look into that too. Consider that.
Oh, the question about the green colors in those.
Yes.
Is that because of the filter that you're using? How does that green turn up when it's?
There are multiple different colors. We just set it to green.
But that's just the image processing. Right? So the camera, the little computer in there, it does an image processing and it paints a green dot when it thinks the image is in focus, and then it takes this, and you have options to configure it as I hear. And it was really just go ahead.
Yeah. So is this measurement dependent on like the speed that you move and also the lighting? Like, will the depth of field change if you have brighter light? It seems like possibly
if you use brighter lights, it'll help the computer inside the camera to recognize the clear edges. So that'll help. That's what Dr. Soha said. That increases the resolution. It doesn't change the optical properties.
But if you're doing tests, as long as you use the same conditions for everything, then you can do internal comparisons. That's really what matters.
Good. Any other comments things that you'd like us to know before we go and we spend all the money?
Well, regarding the distortion thing, so I don't know what's happening with your reconstruction, but you should be able to get the intrinsic coefficients for the system, and then use those in your reconstruction.
Yeah, that's what we have been doing for the GoPros. Right? Estimate those. There's a model for distortion, and it fits parameters to it, and so it can correct the distortion. But of course, the less of it you have to begin with, the better, because no model is ever perfect. Right?
Right. So, like in the case of the GoPros, when you go from the full wide angle to their narrow view, all they're doing is cutting the sensor. and so you don't actually gain anything except speed of processing.
Well, no, I mean, yeah, in the image processing, right? We have a model where we estimate. So there's a model for the distortion, and then that corrects the image based. So you estimate the parameters for this model, and then when you process your images, you can de-distort the images, and that works. It makes it better, but it's not perfect, right? So a lens, we would prefer a lens that has less distortion over later trying to put it back, because putting it back is an estimate and the model is only an approximation of the real distortion that you have there. So it has some kind of distortion. Does anybody remember what the distortion model is like?
I think we're using the polynomial model. And so the thing is, like the radial distortion is not quite polynomial, then you get some sort of deviation between like the actual model. So even when you're factoring that in, you'll still get some sort of nominal error.
So I'm sure that these lenses, right, so the GoPro camera, the whole camera with the lens cost $400. And here we are spending $150 on just the lens, right? So I hope that what you pay for, we also get better quality in terms of distortion. But when you do that, please also run the GoPro in parallel and we take a look, right, how much better we are. And then also Alex's lenses, run them all through this test, and we shall see. But low distortion is also, if you're thinking of image reconstruction, then low distortion is a benefit. But then again, there might be other factors, and it's not that we really have to.
I think you're, correct me if I'm wrong, but you're talking about two different things. You're talking about how much does this lens warp the image, and then how uniform is that warp? Because you can have aberrations from that mess up with your model.
Yeah.
You can have a very nice lens that, say it's a very wide angle lens, but it's a beautiful Zeiss lens that costs $4,000 that is extremely well crafted and is extremely uniform and has very little aberration.
Yeah, that's good.
But there's still a lot of distortion protected. That when you correct it, you'll have lower errors.
Right.
Those are two separate.
Yeah. So it could be like highly distorted, but if it's distorted in a perfect circle, then your model will perfectly match the lens.
Right. So it's in a sense you're talking about the quality of the lens, because the smaller your focal length, the more distortion you're going to have in general. But the wider field.
Yeah, I'll try some reconstructions also. I mean, one is take some images where we can see the distortion, but so we can see for ourselves, right? How big is it? How regular is it? And then try to fix the distortion, try to take it out, and then again we can see how well does that work, and then try your 3D reconstruction and see how well does that work, right? And then after you're done with that, we'll spend the money. I think that's probably the prudent way to do it here. And again, I mean, it will not be perfect, and it doesn't have to be, but we want to make a reasonable choice. Okay. Thanks much, everybody. And for the next day, for the next week, do we have somebody or?
Yes, we can move it to Friday.
Next week. Oh, good that you remind me. Next week we have a guest, right? From so next week we have somebody from South Carolina State University who is writing a book on bioinspiration, and so he's a I don't know, literature journalism professor, and he is writing a book on. So it's not editing like an edited volume. He's writing a book himself, but he needs stories. So he's going to come here to talk about his project and talk to us here. And so because his schedule doesn't permit him to come on Wednesday, next week we have shifted it to Friday. So please mark your calendar. No pizza on Wednesday, so don't plan on getting that pizza calorie burst. And then if you don't get it, you'll starve, but it's not going to happen. It will be on Friday. So next week I'll see you. It's the same time though, right?
Yeah,
so same time, same place, just Friday, right? Yeah. Good. And then after that, do you have, okay, so for the rest of the semester, the schedule